Let's start with that. Simple interest is about numbers, what happens to exchange rates and all that. Okay.
Do you know who do first?
Simple interest. So simple interest and compound interest. Simple interest. Well, interest is basically the amount of money that is accrued to an investment. You know, for instance, if someone deposits a particular amount of money, say £500, for a certain duration, like 2 years, at the end of 2 years, obviously he's not going to get just £500. There will be some additional money, like profit, that will be added to what he deposited or invested. So when he's collecting the money, the full money, he will get his investment, which we call principal, together with the interest, like the profit. Did you get that? Now the two together will sum up to what we call amount. I'm going to give you a simple equation that can connect all of these. So it can also apply when someone borrows some money from a bank or from an investment company, and when he wants to pay back, obviously he's going to pay that amount he borrowed, which of course is a principal, plus a certain interest that the investment company or the bank will charge him for using their money to do business. So what he's going to pay will not be exactly what he collected. He will pay that plus something, which is the interest. The two together is the amount. So the principal is what is collected. Did you get that? So in talking about simple interest or interest and problems of simple interest, you need to consider what we call principal is the initial amount invested or collected, the initial amount invested or borrowed, as the case may be. So let me just use simple terms. Initial amount borrowed or invested, that's the principal. So principal will represent principal with letter P. Are we concentrating? Then you have the interest. Interest is like the profit on that principal. Interest. I. So of course interest is the profit. Profit or charge, as the case may be. So you can think of it as a profit. So I'll just use simple terms. Profit on your investment. The profits on the investment, or the charges based on if you borrowed it. Now you have, of course, the number of years, time. These are things you look at when you are. The time is the duration of the investment. Time, of course, T is the duration of investment, usually in years. Usually in a number of years. And then the rate. The rate time is T. Rate is the percentage charge based on the principal. So rate I will explain. Assuming, are you listening to me?
Yeah.
If I collected 200 naira and the percentage charge is 10%, what is the charge? It's just an example. 200 naira was collected, or 200 pounds. Now, if the percentage charge is 10%, what's the charge? You know, that's 10%, that's 10 over 100 of 200, isn't it? So the rate is like the charge.
So what is it?
The rate is like the percentage charge on the principal.
What is 10 over 100 from?
You know, percent means
10.
over 100. No, percent itself means over 100. Percent. The word cent is a word representing 100. Like a century. Just like deck is about 10.
Yeah.
Alright, so percent. So if I say percent, it means per 100. If it is 5%, it means 5 over 100. Per 100, percent. Cent itself means 100, okay?
Yeah.
Alright, we looked at percentages and all that earlier. So you will need to review those lessons and see how they connect. So rate is like the percentage on the principal. The percentage on the principal. Alright, so simple interest. Simple interest, we represent it with SI. The formula for simple interest is SI. It's a very simple formula we know. Principal times rate times time. Did you see that? Now, you might want to say over 100. Obviously, we know rate is over 100. So, principal times rate times time over 100. After all, rate is over 100 anyways. So, principal times rate times time over 100. So, a simple example. Examples. Number one, calculate the simple interest. The SI. SI stands for what? Okay, calculate the simple interest on an investment of $20,000 for 5 years at the rate of 2.5%. That's simple enough. So the formula is what?
Simple interest.
SI is what? PLT over 100, which will be
20,000.
the principal is a 20,000, which of course is a major investment, the initial amount invested or borrowed. So 20,000. Okay. So let me write the R properly. So that's 20,000 times 20,000 times the rate is 2.5 times the time is 5 years all over 100, because rate is over 100 anyway. So it's basically P times R times T, since we know the rate is over 100, or you might just write PRT over 100. Okay, quickly, let me have the answer. Check, get the answer with the calculator. 20,000 times 2.5 times 5 over 100. What do you get?
Oh, that one.
Pardon?
1,500.
So $2,500 will be the interest. 2,500. 2,500 pounds rather. So what will be the total amount the investor will receive at the end of 5 years? What will be the total amount? Did you hear me? If you invested this amount, what will be the total amount you will receive at the end of the duration of the investment? Total amount will be what? By the way, total amount is represented by capital letter A. Total amount will be what? Yes, you invested £20,000 and then you got this £2,500 as interest. So what will be the total amount you'll be given at the end of 5 years? Yes, what you invested plus your interest. So what's the formula connecting total amount with all of that? Sorry, let me write it on the next page. Principal plus interest, that's correct. So total amount will be principal times plus interest. Take note of that. Total amount is what you will get or what you will pay, as the case may be, based on if you invested or you borrowed. Total amount, which we represent with A, is equal to principal plus interest. So A is equal to principal plus interest. So for that investor, his total amount will be equal to principal is 20,000. Okay, 20,000 plus 2,500, and that is 22,500 pounds. Okay, so that's how easy this can be. I can give you other examples. Sometimes the question can be structured in a way that you will probably look for one of these. Maybe the interest is given, and then you're asked to find the principal, or even the time. It's just making something say the formula, isn't it? Shouldn't it be? That would be simple making something subject of formula. If the interest is given, or simple interest is given, and you are asked to find the principal. Can I just show you something like that? If simple interest is equal to principal times rate times time over 100, how do we get principal, for instance? Assuming simple interest is given. If simple interest is given and rate is given, time is given, but you are asked to find principal, how do we find that? How do we find that? Okay. You make it subject of formula, of course. Look at what I'm saying. Simple interest is what is given. Principal is not given. Rate is given. Time is given. You just make principal the subject of formula. How do you make principal subject of formula? You cross multiply, isn't it? Yeah. Let's do that. What will you have? Cross multiply to make principal subject of formula. This is like over 1, I hope you know. So cross multiply, what will you have? Let's go. 100 times simple interest, is it not? It's equal to principal, or I can actually write principal times rate times time equal to 100 times simple interest. I'm cross multiplying because I want to make P as the formula. Are we see here? Alright, so P times R times T, the whole of this times 1, that's this times this, is equal to the other one times the other one. It's equal to what? 100 times simple interest. So make P the set of formula. What will you do? Divide both sides by R and T. So P will be equal to 100 times S, simple interest, divided by rate times time. So whatever is given, you can get the other one. It's as simple as that. Just make the required variable the solid formula. You make principal the solid formula if principal is required and the rest are given. Simple interest is given, time is given, rate is given. You ask to find principal. Make principal the solid formula, and it's just simple cross multiplication. 100 times simple interest, that's 100 times simple interest. Principal times rate times times 1, which is this. Now you divide both sides by rate and time. You're going to have principal equal to 100 times simple interest divided by rate times time. Can we use a simple example to illustrate this? Okay. So a man borrowed a certain amount of money from the bank at the rate of 5% for 10 years. If after 10 years he paid an interest of 8,500, how much did he borrow? I think we can do this right away. What are we looking for here? Look at the question and let me know what we're looking for. Are you thinking about it? So what are we looking for? What are we expected to find?
We're looking for principal.
Principal, yes. We're looking for principal. Alright, so let's just apply this simple formula without wasting time. Principal is 100 times simple interest divided by rate times time, isn't it? So the principal is 100 times simple interest. So that will be 100. We're applying this formula. That will be 100 times what?
Simple interest.
What's the simple interest? So 100 times, what's the simple interest in the formula? 8,500.
Yes, that is.
Divided by rate. Rate is 5. Then times time. The time is 10 years. Alright, let's go. What did you get? $100 times 8,500 times divided by 5 times 10. That's like 16,500. That's a terrible investment. He almost paid half of what he borrowed. $100 times 8,500 divided by 5 times 10. I know it will be 17,000. That's a very, very bad investment. This man is paying almost double of what he borrowed. What do you say it is? 17,500.
17,000.
17,000.
Yeah.
Okay, after 10 years, he paid almost half of what he borrowed. That's really, really very serious investment. So this is the principal. $70,000 was what he was given during the negotiation period. You know, I think this is clear. I want to structure the question slightly. Are you ready? Of course, I've given you. Do I need to do that? There's no need. You already know that total amount is principal plus interest, isn't it?
Yeah.
Okay. Let's look at compound interest. By the way, what is it about compound interest? In simple interest, are you listening to me? We don't have to keep increasing the amount borrowed every year, as it were. But in compound interest, the total amount changes every period. I will explain. I will explain. Now, in compound interest, as the name implies, the principal is compounded, or rather, the interest is compounded. The interest is compounded. So, look at an example. Before I apply the formula, I will show you how it is done. In a very literal way. So, look at an investment. An investment. Are you listening? An investment of, what can we use? Any example? Any value? $25,000. Or maybe I should still use the same $20,000. Let me use that same $20,000 so you see the difference. The first one we did was $20,000, was it? Was it $20,000?
Yeah.
The first example, the principal was $20,000 for 5 years at the rate of 2.5%. But these rates are too upward. And by the time we do it for 5 years, it will be too long. But I want to do it for just a few years to explain something. Now, an investment of $20,000, let me do for 3 years. For 3 years, at the rate of,
So what formula for compound interest?
I'm going to give you the formula, but I want you to understand what it is about. An investment of $20,000 for 3 years at the rate of that same 2.5%. I can do it for 5 years, but it's just too long. Okay, it will just be too long to keep doing it up to 5 years. So let me just do for 3 years or even 2 years. If we have the luxury of time, I can make it up to 5 years. So an investment of this same amount, 20,000 naira or $20,000 or pounds, whatever we used, for 3 years, at the rate of 2.5%. Let's go. Are you ready? Now, in compound interest, because I said it's going to be compounded, you do for the first year. First year, after the first year, is what I mean. What will be the interest after the first year? We'll find the interest after the first year. Let's go. Interest is principal times rate times time over 100, is it not?
Oh.
Which is what? Give me, impute those values. Principal times rate times time. What's the principal? 20,000 times rate. I need to conserve space. It's principal times rate times time. Principal times rate times time over 100. So after the first year, what's the principal again? That same principal, 20,000 times.
So why can't we just 6 times 3?
No. I'm doing compound interest. If you are doing compound interest, that interest is compounded.
Yes, sir.
So it's a different.
So, but we know that it's compound interest, but in a question, how are we going to know if it's compound interest?
It will be stated. They will tell you compounded.
Okay.
The question will state that the interest is compounded, right? You're going to see a number of examples I will show you here. For compound interest, it will be indicated it is compounded. You understand? All right, so let's go. I need you to give me the answer for that 20,000 times rate, 2.5 times time, that's 1. It's just after 1 year.
Oh, shit.
You didn't use 1. Okay, times 1.
500.
Divided by what? 100.
500.
You got 500, right?
Yeah.
So you got 500. That's after 1 year. Now the way this thing is done for compound interest is, after that 1 year, the principal is going to change. What the bank thinks is, you are now going to borrow from us that 20,000 plus the additional 500. It's no longer 20,000 that you are owing us. Let me ask you, if this, this is an investment for 3 years at, okay, it's an investment. Was it the way I structured the initial question? Calculate the sum of an investment of 20,000. Okay, so since it's an investment, it's not some money borrowed. It's someone's investment where he expects to get profit. That is added. Now, think about it this way. Are you listening to me? You invested this money into a bank at this rate, which both of you agreed to use for your investment. After 1 year, how much will be your interest? That's what we have found, is it not? If you collected your money after 1 year, how much should they give you?
After 1 year?
Yes, now, if you collected your money after just 1 year, how much should they give you? Because these are simple, practical things. Assuming you collected your money after 1 year, how much will they give you?
Who understands?
But you've been following me all this.
500.
500 is your interest. I said if you collected all your money. Am I not speaking simple language? This is what you put into the bank, 20,000. And this is the interest, like the profit. So if you are going to ask them, give me all my money after 1 year, what would they give you?
Your own money.
Which is?
500 plus 20,000.
Say that again.
20,000 plus 100.
20,000 plus 500. And that is what?
25,000.
Are you sure?
20,500.
So after 1 year, that is how much the bank will give you, right? So after 1 year, the new amount of money you have will be 20,500. All right, so the new amount after 1 year. How do I think I should use a different color so that this will make sense. Amount after 1 year is 20,000 plus 500, or if you can say principal, the initial principal plus the new interest now, which is 20,000 plus 500. All right, I think it's better to write it over there. So this will be equal to 20,000 plus 500, and you said it is 20,500. After 1 year, this is what you should be given by the investment company. Assuming you decided not to collect the money, you want to reinvest it. That is what we now call compound interest, because if you reinvest it, it's going to be compounded. You know, when we say a problem is compounded, it's like it is adding up. Did you get that? It's adding up. So for the second year, we go for the second year. Second year, for this second year, what will be the new amount that you are putting in? 2,500. So that's the new principal. For this second year, the new principal is now 2,500. Because that's what you are putting in there. $20,500 or pounds, whatever the currency is. So what will be the interest? Let's calculate the interest again. Interest will be principal times rate times time over 100. Which is 20,000 times that times that. Let me get the answer with the calculator. Can you get the answer for me?
1,025.
Are you sure it's up to that?
Yeah.
It looks like that number you're giving me is a little bit on the high side, but I need to confirm. 20,500, is that what you did? Times 2.5 times 1 over.
So why is not times 2?
No, it can't be, because you are doing it. You see, your interest is every year. No wonder you were getting something different. But I like your question. You are calculating the interest every year. This one is now the second year. Times 100 over 100. So what is that?
So give me a decimal.
No problem.
Oh, 512.5.
512.1.
5.
Okay, 512.5. Can you give it to me into 5 significant figures? 5 what?
There's only 4.
Let me see it. Okay, maybe your calculator is set to 4 significant figures. So 512.5, right? So this is the new interest after the second year. Now, if you are going to the third year now, that is, if you don't want to take your money again, you are investing it into the third year because you want it to be 3 years of investment. The third year, what's the new principal? So that you see what I mean by compounding. What's the new principal for this third year? How do you get a new principal? I want to ask you.
Yeah, adding it now.
Adding what to what?
512.5
Plus.
20,500.
Yes, plus 20,500 plus the initial thing you for that second year on that second year. So the new principal will be 20,500 plus 512.5 according to what you gave me. So that would be what? Please read it out.
210.2.5.
Okay, so 210.12.5. 210.12.5. Are you sure? 1 2 3 4 5. 1 2 3 4 5. Okay. 210.12.5. This is the new principal. So if this is the new principal, let's see what the interest will be. I will run through a summary for this. So the new principal will be interest will be principal times rate times time, also over 100. So what was that? 210.12.5 times. You are going to engage your calculator seriously. 0.5 times the rate is 2.5 times 1 over 100. So what does that give? 525 point anything. 0.525 point
3125.
0.32. You know, we just use this.
3125.
You know, eventually we'll round off to 3 significant figures. So all of them.
Explain?
I will definitely. I will.
That's
So
212.
you gave me 525.3125. 312. Okay, so 31. Let's just leave it at 31. That's a good reminder. So 31 is the new interest. So at the end of 3 years, how much is this man going to get in total? So total amount at the end of 3 years. Of total amount at the end of 3 years will now be that principal plus this interest, isn't it? Principal plus interest, which is what? I will run a quick summary of this. Need to zoom out a bit, zoom in a bit to capture it. So principal plus interest is what? What's the principal again? Remember the principal? 21012.5, because that's the new principal you invested in that year, on that year, in that particular year rather. So that would be 21012.5 plus this new interest he has made, 525.31, and so on. Okay, that the total amount will now be what? 21012.5. Please use your calculator to back up the what your sister is doing so that we can work faster. 21012.5 plus 525.3. That gives what?
21537.8.
21537.8. That's the total amount after this period. If the interest is compounded, now this is about compounded interest. Compounded interest, as the name implies, is you are adding the interest every year to recalculate the principal. There's another formula we use. In fact, a simple formula we use for this is amount is, are you listening? Principal, you open a bracket, 1 plus rate. Of course, that rate should be over 100, if you like, rate over 100, or reciprocal n, where n is the number of years. So I will just indicate this is principal. I can just call this thing time, so that doesn't. Reciprocal t. R is rate, of obvious already, we know. We know the other symbols, so I just have to just include t. T stands for number of years if it is compounded annually. If we apply that, we will get the same answer. Apply that formula. So A will be equal to, what was the principal? 20,000. Then 1 plus, what was the rate? 2.5 over 100. Then raise it to power, the number of years, 3. You get the same answer, or approximately that value. I want you to try it. You get the same answer. So, of course, you will get the same answer. Then you got what? Read out the values.
21537.8.
Just a moment, let me write it down. 21537.8 pounds. The same answer. Okay. This is about compound interest. Like I said, compound interest is the interest compounded every year. Unlike simple interest, which is we look at the end of the 3 years and then we calculate it based on the rate. In fact, you're going to see the difference. For compound interest, we look at it every year for the number of years given. Now this investment is for 20,000, right? And it's going to be run for 3 years at this rate, 2.5%. So what we do is we work for the simple interest for the first year, and that gives us 500 pounds, right? So the new amount after that first year will be principal plus interest. The total amount you will collect will be your principal together with your interest, like your profit, is it not? And this is what you will now have at the end of that first year. Assuming you didn't want to continue with the company again, you were tired of the investment, you will go home with this your money. You are going home with your 20,000 together with your 500. That's 20,500. But if you wanted it to run for the whole 3 years, that means you're going to reinvest it for another year, which is the second year. Now, what are you reinvesting now? 20,500 because you did not collect anything from them. That's why the new principal now will be 20,500. No longer the 20,000 you put in. So the new principal is now 20,500. You walk through the math again. So 20,500 times 2.5 times 1 over 1,000. You know, interest is principal times rate times time over 100. So this is now a new interest. What's the new interest?
512.5.
Now, if you are tired of the investment, you will collect 512.5 plus this thing you put in. What did you even put in this second year?
20,000.
So the new principal you are starting with for that year is 20,500 plus 512.5, isn't it? Are you getting the gist?
Yeah.
This is why the new principal is 20,500, which of course was what you had at the end of first year, plus this new interest. So your new principal is 20,500 plus 512.5. So this is your new principal. Now, if you are continuing in this third year, that's what you will use to calculate your interest. So principal times rate times time over 100 will now be this 21012.5 times 2.5 times 1. But you must be careful because you are calculating the interest every year. So the time is always 1 year because you are calculating it every year. Did you get what I'm saying? Don't make the mistake of putting 2 here because it's on the second year. I said second year, not 2 years. So you are doing it again on the second year. So the time is always 1 year if you want to use this method. Your sister asked that question. Is it clear?
Mm-hmm.
So you do it again, and this is now your new interest. So at the end of the 3 years of investment, how much will you now collect? The principal you put in on that third year now.
So I thought.
That's the thing you must be careful about. Is this principal you put in plus the new interest?
Is it for the last day?
Yes, the new principal in fact the most current principal plus the interest is now.
It's 5 years. You use the principal for the.
In fact, if we were going to do for the fourth year, this is the principal we will use. This is the principal we're going to use for the fourth year.
Yes, plus.
No, that we use this principal to calculate and then get our interest, and then we move it on to. This is what you are trying to. This is the question you're asking. After the first year, this is the principal. After the first year, so for the second year, this thing we had will now be our new principal.
Yes.
And then this is the interest. If we are continuing with the investment on the third year, for that third year, the new principal will be, this plus this, is it not? That's what we did. And we'll calculate our interest again. If we are stopping on the third year, we'll go home with this amount. But if we want to continue again, we're going to use this as a new principal. Calculate again, get an interest, and on and on and on until we run through the years. Now, if you don't want to use the method I said, you can just use this. Amount is principal, open a bracket, 1 plus the rate, of course, the rate is over 100. Close the bracket, all raised by t. Why t is what? Number of years. And you will get the same answer as what we got here. The same answer. Whichever method you use, like I said, you will get the same answer. But when you are imputing this in a calculator, you should be careful. 1 plus r over 100 first. Or if your calculator has a good algorithm, if you enter all this, it should give you the answer directly. Now, in this case, if I may ask you, what is even the overall principal? Overall interest. What's the overall interest? This is what this person got at the end of 3 years when the interest was compounded. But what is actually the overall interest? Remember, this what you have here is the amount. Is what?
Amount.
That's amount. That's amount. So what's even the overall interest? Don't forget what we said. What's the formula? Look at it here. Amount is what?
Plus principal.
Amount is principal plus interest. So to get interest will be what?
Principal minus amount.
Interest will be what? Amount minus principal. Yes. So from A, which is P plus I will be equal to P minus A minus P, isn't it? So A minus P. So it's like asking what was actually the real profit this guy made from the investment. What was the real profit he made? What was his actual interest? To get that, we just simply do amount minus P. What's the amount again? 21537.8 minus the original thing he invested. I hope you know.
It's not 20,000.
20,000, good. The original thing he invested 20,000, and I think that should be 21537.8. That should be 1537.8. I want us to see how it is better than just a simple interest. You will see how this is better than just a simple interest. And I will do it on the same page. You will see how this thing will give you something better than simple interest. If it was a simple interest for the same amount, let me, what color can I use? Let me use black. For the same initial principal, invested, or let me just say initial principal of $20,000 pounds, invested or £20,000 investment at the rate of 2.5% for 3 years. Let's see what the simple interest would have been, just a simple one that you don't have to be compounding. So you see how it differs. There's usually a significant difference. In fact, this compound interest is usually, we usually produce a bigger amount. It may be a little bit bigger, but it will definitely be bigger. For the same initial principal of 20,000 investment at the rate of 2.5% for 3 years, the simple interest, SI will be what? What's the formula again? Principal times rate times time over 100. So let's do that. That's 20,000 times 2.5 times the time is 3 years over 100. See what it gives and compare it with this, the one we got. Please, I need you to get the value. 20,123 times rate 2.5 times time 3 years. Okay.
1,500.
1,500. So which one is bigger?
This one.
I had a feeling that it would be 1,500 in anyways. So 1,500. So you can see that the one for compound interest produce a bigger amount, or produce a bigger interest. So compound interest will always produce a bigger interest because the interest is compounded. Are you looking at this?
Huh?
So what I was just saying, please listen up. What I was saying is if it is the same amount, the same principal that was invested at the same rate of 2.5 for 3 years, now the simple interest is just the normal formula, principal times rate times time over 100, which of course is 20,000 times 2.5 times 3 because we're just doing it directly. Do you understand what I'm saying? No, it's compounding. I'm calculating simple interest. Are you listening to me?
Yes.
Are you sure?
Yes.
So 20,000 times 2.5 times 3 over 100, and that gives us 1,500 pounds. Compare it with what we got for compound interest. You can see the one for compound interest is bigger, isn't it? All right. So it is not just about money. You can also use this to calculate changes that occur or increment that occurred exponentially, what we call exponential increase or even exponential decrease. I'll give you an example. Will be left after after 5 minutes. You see that? After 5 minutes. So let's see the information given. You know, I said principal, rate, time, but this one you can just talk about initial amount or present value. The principal is actually the present value. The amount is actually the future value. PV. The amount is the future value, FV. What's the present amount of? Remember the question says the population of a certain bacteria decreased exponentially at the rate of 3% every minute. If the initial population was 500,000 bacteria, find it to the nearest whole number how many bacteria will be left after 5 minutes. Will be left after 5 minutes. Please, before you copy that, you need to watch what I'm doing. You will copy that later.
No,
I will make sure you find the time to copy it. So because I want us to quickly, I want to introduce something, a little twist, so, and I don't want you to miss it. Left after 5 minutes. Present value is like the principal, like what you started with. If it was an investment, what you put in. So present value, you can call it PV. The amount, what it will eventually become after a number of years of investment, is the future value. So you can call it FV. All other things stay constant, like rate and time. So instead of saying, just compare, instead of saying amount equal to principal times rate, what was the formula for compound interest, by the way? Equal to principal, open a bracket, 1 plus
1 R over 100 raised power.
And I want to say something here, R over 100 raised to power time. I want you to see that this is a decrease. It is not increasing. Are you listening to me? This is a decrease. It's an exponential decrease. It is not increase. It's not like an investment that will keep adding values. This one is reducing in value. So instead of 1 plus, we're going to do 1 minus. Take note of this, very, very important. If it's something that is going to decrease, it's 1 minus, you do. If it's something that you know is going to increase, 1 plus. Is that clear?
Yeah.
So this should actually be 1 minus R over 100 square T. So, which of course will be future value. You can still change it to all of that. So future value, because I said amount is the same thing as the future value. Future value is equal to what? Present value, which is the principal, 1 minus the rate over 100 raised to power t, isn't it? So let's go. So what's the future value now? What was the present value? 500,000 bacteria. Please put in those values quickly. 500,000 bacteria. Open a bracket. 1 minus the rate is 3 over 100 raised to power. The time is 5 minutes. Because it says every minute. So the time can be 5 minutes. It's not about years. Can I have the answer? 500,000, open a bracket. 1 minus
4
raised to power
429.
429, you sure?
So it was a long.
429367. 429 429,367, because it's to the nearest whole number. This is what will be left, and you can see this is smaller than what it was before. This is 429,367 out of 5,000. So how much bacteria probably died or disappeared or whatever, which is like the interest. Did you get that? Because we said interest is amount minus principal, is it not?
Yeah.
So how many bacteria actually left, as it were? You can think of it like that. So what can I call that? Change, if you like. The change will be what it was initially minus what it is now, because what it was, the difference between what it was initially and what it is now is just about difference. I can just call that difference, if you like, difference. Because sometimes you may be asked to calculate how many bacteria died or something. So the difference is what? Are you getting what I'm saying?
Yeah.
The difference is just the difference between the two. And of course, in this case, the future value looks like it's smaller than the initial value. So it's just a positive difference. The bigger one minus the smaller one, that's what I mean. We would have said 429,376 minus, because that's the amount, minus principal. 429,376 minus 500,000, but that will give us negative. So the difference is what we call absolute value. One minus the other, but what we're looking for is the numerical value, not interested in the sign, just the difference. So difference is 5,000 minus that, 500,000 minus 429,367. Did you get that? What did you get? 70633. 70633.
So
Just a moment before you get that. 70633. All right. Can I get your question now? So that's the difference. That's the amount of bacteria that will be left.
Jawab.
Are you still asking the question? Are you good now? You're fine, eh? Good.